Okay, so we've done some of the basic setup work that we need, and we're ready to look at basic trigonometry, which is trigonometry in the sense of right triangles. This is foundational to most of the other things that we do in the class, so pay attention. Wake up. All right, I'm just going to draw a little triangle here. A little right triangle, and my little 90-degree guy there. And I'm going to draw an angle here in the corner, label it theta, and give you the basic definitions. So sine theta, cosine theta, tan theta. So first of all of these are just ratios. And I think the general concept was a recognition that if you have the same triangle, but just, a larger or smaller version of that same thing, you're going to have these kind of consistent side ratios. This is a concept called similar triangles. So we can codify that by saying the sine of this angle is the opposite side over the hypotenuse. And the cosine of this angle is the adjacent side over the hypotenuse. And the tangent of this angle is the opposite of the adjacent side. So it's just ratios of sides. Now, the hypotenuse is the longest side in the right triangle. And it's the one that's across from the 90 degrees. The opposite and the adjacent side are the legs. And who's opposite and who's adjacent is not fixed. It's relative to where you're standing. So if you're standing over here in this corner, then this is the opposite side and this is the adjacent side. But if I switch my perspective and say, oh, I'm going to stand over here, let's use a different angle instead of theta. Let's use phi. How about that? So if I'm standing over here, then this becomes the opposite side. This becomes the adjacent side. It's adjacent to the angle, the side that is connected next to the angle. The opposite side is the one that is across from that same angle. Okay, so that's the concept of the naming of adjacent and opposite. So the very first place to start is just to take a triangle where you're provided two sides, and then you come up with the sine, cosine, and tangent ratios using the Pythagorean theorem, and then just building the ratios based on who's opposite, who's hypotenuse, etc. So let's see. I'll erase some stuff so I don't have to rebuild this triangle. I can leave the definition there. Okay, so let's say that I tell you that this side is 12 feet and this side is 30 feet. I didn't tell you about this side, but based on this information, you can provide me with the exact answer for what is sine of, let's switch our perspective over here. What is the sine of theta? What's the cosine of theta? And what's the tangent of theta? Now, the sine of theta, we can go right away and say opposite is, again, tracking to the other side of the triangle, 12 over 30. I didn't really write the units because it's going to be feet over feet, so they'll simplify. Of course, 12 over 30 simplifies to 6 over 15, which simplifies to 2/5. The rest of them, I'm going to need to use the Pythagorean theorem to figure out the missing side. So remember, the Pythagorean theorem is x squared plus 12 squared equals 30 squared, right? Based on the square of both of the legs added together is equal to the square of the hypotenuse. So now I just need to do a little bit of math. X squared equals whatever 900 minus 144 is, 756. And then we got X equals the square root of 756. Now, sometimes you're going to need to give these as exact answers. Sometimes you can do decimal approximations. If this is an exact answer, then I'm going to need to simplify this radical, and I've got a video that walks you through how to do that sort of step by step. I know that 756 is 4 times 9 times 21. And so this is going to be X equals 6 square roots of 21. And so at that point, I'm going to go ahead and erase this. And I'm going to write in 6 square roots of 21. And now I'm going to set up my other ratios. Cosine is the adjacent over the hypotenuse. So 6 square roots of 21 over 30. Again, I can simplify that, square root of 21 over 5. And tangent is going to be the opposite over the adjacent side. So 12 over 6 square roots of 21. And that's 2 over the square root of 21. If I want to rationalize it, square root of 21, square root of 21, multiply the top and the bottom, 2 root 21 over 21. Okay. From my perspective, I don't really ever care about whether you answer like this or whether you answer like this. All right, so that's basic trig. And we're going to go further with that because, eventually we're going to answer questions where maybe we know the angle and a side and we're going to figure out another side. If I know a triangle's, this is a right triangle and I have an angle and I have one side, I can use that to go forward and figure out all of the other missing sides. So I'm going to just show you an example of that. Eventually, we'll be able to also work out missing angles if we have two sides. So there's a lot of ways that we can use trigonometry. Super powerful, and ancient peoples, the Egyptians, the Greeks used it to do all kinds of crazy things, figure out the radius of the earth and figure out how far stars were away and the sun and all kinds of stuff. It's really quite remarkable. Okay, so let's say I've got a 40-degree angle here, and this is 16 feet, and I want to know how far that is. So the first thing I need to do with that kind of problem is to look at it and say, which of the three relationships is important here? Because one of these three, sine, cosine, tangent, is the perfect relationship in the sense that if I stand in this corner and I look at this side and this side, that's either sine, cosine, or tangent. Have a second to think about that. Okay, so it's sine because if I stand at the 40 degrees and I look across, that's the opposite side and I have the hypotenuse. So sine 40 degrees equals question mark x over 16, right? Now this is a number. So if I go to my calculator and say, hey, calculator, what's sine 40? And I press enter, I get 0.643. I'll just go to the thousands place here. Equals x over 16. Call this x instead of question mark. I'm used to teaching quantitative reasoning where I try to stay away from variables. Now, just a quick point here, and you're going to have to go back and forth in this class, but you're going to have to be able to use your calculator to use degrees sometimes and use radians at other times. Since this is degrees, my calculator's in degree mode. If you put in sine 40 and you got something else out, you're probably in the wrong mode and you need to check in with me or Google, Mr. Google, and see how you change your calculator's mode. From there, just a very simple algebraic problem, inverse operations. I'm dividing by 16 here, so I multiply by 16. So x equals 16 times 0.643. This is not the kind of problem where you would need to answer exactly. So I'm looking at about 10.3 is my missing side, and it's feet because that was the units of the original thing. Okay, so that's an example of how we use sign in context. Now, this is not a word problem. I've still given you a very abstract problem with just numbers provided, but you'll definitely run into word problems where we're going to need to use trigonometry to figure out, basic trigonometry to figure out the missing side. All you need is an angle on one side, you can figure out all the other sides. But if I wanted to figure out this side now, of course, I could use cosine, or I could use the Pythagorean theorem, because I know if this is 10.3 feet and this is 16 feet, I can just say a squared plus this squared equals this squared. All right, so that's a basic trig introduction.